The JIMI project is made up of three components, the first of which is initial data collection, which we will show how Transmap assisted with this. The second component is updating of data, which also includes the relocating of assets, and we will show a video where the Carlson GPS units were used to do this. The third component is the reporting system, and we will talk briefly about how Cartograph is assisting with this. Transmap utilizes a van that is equipped with three high-resolution video cameras. One is located in the front of the vehicle, the second one is located on the front right side of the vehicle, and the third one is located in the back of the vehicle. In these pictures you will see street signs, telephone poles, sidewalks, curbs, pavement, and crosswalks. The main deliverable that Transmap was collecting for the project was pavement analysis. The side benefit is that they can extract any assets or features that they can see in the video, giving you X and Y coordinates with sub-meter accuracy, as well as other information for assets like street signs. They can also extract other point assets like hydrants, culverts, bridges, etc. Since culverts can be hard to see, it is recommended that they be marked on the pavement by painting an ID number where it is located. Transmap has the capabilities to incorporate any existing data you have for any asset extracted. Right now we will see a video of Transmap driving a road in West Carthage that you will also see later when we show how the GPS units are used to help relocate assets when covered by snow. Remember, anything you see in the video pretty much can be extracted and put into your asset management software. Here's an overview of the data collected by Transmap. Transmap collected 410 bridges, 5,755 culverts, 1,024 hydrants, 832 manholes, 9 meter boxes, 20,100 signs, 1,491 stormwater drains, 416 water valves, and they also drove a total of 1,379 road miles. The total points collected were 30,037. If it took one person 2 minutes to collect each point, and the person collected points 8 hours a day for 5 days a week, it would take the person 6.5 months to collect all these points. For total mileage, there is 1,379 miles driven. If a person drove 10 miles per hour surveying pavement conditions, it would take 137.9 hours to survey the roads for this project. These do not take into factor weather conditions and or other projects that might be going on. We will now take a look at how the Carlson GPS units will be utilized for this project, especially when you need to respond to an emergency. The question here would be, what would you do if a call came in for a waterline break?
I have a waterline break and my dog is about to float away.
Here we are riding with Tim Turk, who is head of the water department for Village of West Carthage. We've now arrived at the spot where the water line break is, so we've started the GPS unit up, and now we will go ahead and go find where the valve is to shut off that water line. So here's Tim headed over right now, trying to locate that point. Right now the GPS is showing the triangle is where we are now, and the crosshairs up there in the circle, that's where the valve is located. We are about 1.7 feet north of it and 4.1 feet east of it. So we're getting close. we're now just bringing it in, getting a little bit closer to where we're trying to get that north and east direction to be closer to 0, being only 0 feet away. So as we're doing this right about now, Tim is getting that reading that he's looking for. And we'll try to zoom in here a little bit. It's hard to see, but that triangle representing us is right on the crosshairs there, right in that bullseye. So now that we've located where it is, as you can see, you cannot see that valve right now. And so now Tim has gotten the wand, which is a metal detector, to use that to try to find the location, which he has, and it's right there, right underneath the post. And now he's going to chip away the ice around there so we can locate the valve. I think I need one of these things over at my house to chip the ice in front of the garage during the winter time. It'd make work a lot faster for me. And here we go. Tim has now chipped the ice away and found the edge of the valve down here, which is right in there. Now we're on to the second thing. We're going to go find a water valve that is buried underneath a snowbank. Just to show you a different use of the GPS unit in a different situation. So here's Tim. He's now locating the water valve. And same thing as before, you keep working the GPS in, you're getting closer and closer, and you just keep working it until you've gotten those readings to be pretty close to saying that you're only about 0 feet away, both north and east of that point. And he's also right now probably seeing a bullseye on there, and you're just trying to get your little triangle, which represents you, to be right in the center of that bullseye. So now that he's getting fairly close right now, he will now be looking to go get a shovel so he can dig some of that snow away from the area, so we can try to get a little better reading. But here we are zooming in. You can sort of see there the triangles within that bullseye. It's kind of hard to tell there in the video. So right now Tim has gone to get the shovel, and then we will go ahead and shovel out around the stake here, the bowl. So now what he's doing is just trying to get down to the ground level, and then we'll put the pole back on there with the GPS unit. You can kind of picture things, you know, if you're in an emergency, you have to find something pretty fast. You know, you'll see how convenient it is to have this GPS unit at your disposal. So right now he's just going to go back and try to relocate that point. And it's too dark to see, but right now you'd be seeing numbers probably like 0 point something, and that's pretty darn close. So once he's happy with where the GPS is reading and where it is, he'll push the stake in the ground a little bit here, and then that'll kind of mark the spot in the ground where he's going to need to dig. There he goes. Now he's marking the spot in the ground. You can kind of see it there in the center. He's going to shovel out right there. So you can see it's even underneath the sod and stuff here, where the valve is located, and basically one shovel. He has already hit the valve. And we'll zoom in here, and there's the valve. This next scenario would be where if you can't use a wand or metal detector because the valve is located to something that's already metal. In this instance, it'll be the chain link fence over here in the park. So Tim has located it. Now he's headed towards it using the GPS unit to help guide him. So in this case, you're pretty much relying totally on the GPS unit to get you to where you need to be. He has now gotten there. And right now the reading for him seems to be pretty good. He's not moving a lot, so it seems to be settling in right around there. And so now he's just digging the snow out from where the GPS said the valve was located. He's just double checking. And then once again he'll be going to get his shovel so that he can then dig out around that point where the GPS is showing. So he's now happy with that reading. He's going to go get the shovel. So now he's just digging out around there, pulling some more of that snow back, and it's going to be looking at trying to dig out that valve right now. And he's already hit it. And we'll go over here and take a look. And right down there is the valve, right there. The whole JIMI group received GPS training. The first training was done by Innovative GPS Solutions. It was a 4-day training in which they broke the group up into 4 smaller groups. The second training was done by Jefferson County Highway back in early February. This was done by their engineering department. They did this as a refresher course for the group. They put on another training, which would have been the third training for the group, in mid-February for those who were not able to attend the one earlier on that month. The fourth training, which will be a follow-up training done by Innovative GPS Solutions, will be done probably within the next month or two after the Cartograph Mobile is installed and up and running. For the JIMI project, the group sat in on in-class instruction done by Jefferson County Highway Engineering Department. Through this in-class instruction, they then went out in the field and they did some field applications on how to use the GPS units. Here they had a 50-foot tape spread out, and they would take a point from the beginning of the tape down to the 50-foot mark, and taking points with the GPS units, they would calculate the distance using the GPS between those 2 points. The class also was instructed on how to go out and relocate points that were already taken by the engineering department before this training took place. So the group got instructions by the instructors, which there were 2 instructors for the training that went on. And right now they are headed out to go find one of the points. Now the best part about this is, as you can see, as being the video person, you do not have to climb into snowbanks. So step 1, always remember, be the person recording. Here he is locating one of the points that they took, which is a stake holding the guide wire to the telephone pole. Here we are going out right now to go locate another feature that was collected by the Jefferson County Highway Department here. And right now they're just using the GPS to guide them to get close enough to what feature it is. They had no idea what was marked out ahead of time. So they're doing all this by going by the GPS unit. So here they've found what they're looking for. The third component of the JIMI project is the reporting system. The one key component is the Cartograph desktop. That will be your primary asset management software, and we'll take a look at that in a minute. The second component is the Cartograph mobile, and this is a software that will be on the GPS units, which will allow you to update data out in the field and bring it back into the office and have it automatically updated into your asset management database. Now let's take a look at the Cartograph desktop software. For the Cartograph desktop software, you'll notice on the left hand side that there are different views listed there. There's pavement view, sewer view, stormwater view, and water view, and there are a couple other views also that you do not see. With this, you can then manage your water assets, like for instance this one is the hydrant forms, and you'll notice the different information that you can collect, like model number, manufacturer, number of turns to open, and also where it's located. Along with this, you can do inspections of the hydrant and the condition that it's in. There's a thing called the overall condition index, and basically if it's 100, it's in very good shape. You know, if it's down in the 50 range to 75 range, then you're probably in the fair condition, and anything below the 50 would be considered in a poor condition. This will help you in prioritizing what assets need to be looked at first and which ones have priority in maybe your upcoming budget year. The same thing applies for other views, like with the pavement view and sewer view. It also has an overall condition index that you can use to prioritize your assets and which ones need to be addressed first. This was the overview of the three different components that were used in the JIMI project.